in continuation with that video, now I am giving you two examples to show how there is variation in angle of deviation with the change in the angle of incidence. So I told you that in minimum deviation position, the refracted ray is always parallel to the base of the prism. So here you can see this is the refracted ray and this is parallel to the base of the prism. So this case the prism is in minimum deviation position. So when prism is in minimum deviation position, as I told you in the first video, angle of incidence is always equal to the angle of emergence. Only and only in minimum deviation position, angle I is equal to angle E, that is the angle of emergence. Okay. Now in this case, angle I is 48 degree, right? So angle E will also be 48 degree and angle of prism is 60 degree, as the prism we have chosen is an equilateral prism. So the formula for finding the minimum deviation or deviation is, so whenever we have to find the deviation, we have to use the formula angle of incidence plus angle of emergence minus angle of prism. So when we add these two angles and subtract the angle of prism from the sum of these two angles, we get the angle by which the ray has deviated. So in this case, as both I and E are equal, so I just wrote 2 into angle I minus A, as this was measured by using the protractor. It was 48 degrees. So 2 into 48 minus 60 comes equal to 36 degrees. Okay. So I told you in the previous graph that with the first increase in angle of incidence, there is decrease in the angle of deviation. But when we increase angle of incidence too much, that is from 48, now I have changed the angle of incidence to 70 degrees. Okay. Now you see this refracted ray is now not parallel to the base. It is going like this, slightly tilted upwards and not parallel to the base. So angle of incidence on AB is 70 degree and angle 4, that is angle of emergence on side AC, was found to be 33 degree experimentally. Then angle of prism is again 60 degree. So angle of deviation, that is by how much the ray has deviated, it comes to 43 degrees. Okay. And if we decrease the value of angle of incidence to 30 degree, there is further, fall in the deviation, right? So with the increase, first it decreases, then it comes to minimum value, and on further increasing it starts increasing. And this deviation depends directly on angle of incidence, directly on the angle of prism. That is, if you use some prism where angle of prism is not 60 degree but more, so the deviation will be more, and if you use a prism with A less than 60, then there will be decrease in the deviation. Okay. And more the refractive index of the prism, that is the material of which the prism is made up of, more will be the deviation, right? But it is inversely proportional to the wavelength of the incident light. More the wavelength, less the deviation, and vice versa. So thank you so much. I hope you have understood the refraction through prisms.